Hi, in this session, we're going to go over rational expressions, and the objectives are to specify numbers that must be included from the domain of a rational expression. We're going to simplify rational expressions and also multiply, divide, and add, subtract rational expressions. So we have first, I guess, should look at what is a rational expression. It's a quotient, or it just means we're taking two polynomials, which we looked at examples of polynomials last time. We're dividing two polynomials. So here is the first example, x minus 2 over 4, 4 over x minus 2. We have x over x squared minus 1, and x squared plus 1 over x squared plus 2x minus 3. So these are all just different examples of rational expressions. Let's take a look at domain of rational functions. The domain is a set of numbers we can plug into the x values. So it's all the possible x values that we can use or that goes into the function. Remember that we can't divide by 0. And so, for example, if you try to divide 5 by 0, you will get an error because it's just undefined. We can't calculate that. Therefore, we have to remember to exclude or leave out zeros that make the denominator 0 from the rational expression. So let's take a look at how we can determine the domain of rational expressions. And so here is an example. We have 4 examples here. We have 3x plus 5 over x. And then we have x in the denominator. It doesn't matter what is in the numerator in the case of where we're trying to find the numbers we need to exclude from the domain. What matters is what can we not plug into the denominator, or what values will make the denominator 0. Well, if we plug in 0 and for x, it'll make the bottom 0, right? So we say in this case that x cannot be 0, because if we plugged in 0, we would get 3 times 0 plus 5 over 0, which would give us 5 over 0. And remember, the previous page, we said we can't divide by 0. So we say the numbers to exclude from this first expression is 0. We can't substitute 0 into this expression. Let's take a look at B. The numbers to exclude from 7 over x plus 5. Well, think about what will make x plus 5 be 0. So we don't want x plus 5 equaling 0. And so if we subtract 5 over to both sides of this, I guess, not equal to sign, we have that x can't equal -5. And that's because, again, you can plug it in to check it out yourself. If we plug -5 in for x, we get -5 plus 5, and that'll give us 7 over 0, which we can't have. So the number to exclude from the second expression is -5. For C, we have 7x over x squared minus 5x minus 14. This case, again, we're trying to see, remember the top, it doesn't matter if that's 0 or not. We can kind of just ignore what the numerator is. Remember, we're focusing on what will make the bottom expression equal 0. And so if we take x squared minus, oops, typo there, minus 5x minus 14 equal, or we don't want it equaling 0. So how we can solve this is, in the previous lesson, we had gone over factoring. We have to factor this expression, and just to do a real factoring, right? If the leading coefficient is 1, we can take the last number, -14, and write that there, and find two numbers that multiply to -14, but add to the middle term, which is -5. And that's going to be 7 and 2, with the 7 being negative. And so this factors to x minus 7 and x plus 2. And so we can set x minus 7 not equal to 0, and then x plus 2. We don't want that equaling 0. We add 7 to both sides here. We get x can't be 7. We subtract 2 over on both sides here. We get x can't be -2. And you can try it out. Plug in 7 in here. If you do 7 squared, minus 5 times 7 minus 14. That's going to give you a value of 0. Same thing for negative 2. If you do negative 2 squared, that'll be 4. And then negative 5 times negative 2, that'll be positive 10. 4 plus 10 is 14 minus 14 is going to give you 0. So the numbers to exclude here again are 7 and negative 2. Okay, for D, we have x plus 7 over x squared minus 36. And we take the denominator. You see, all right, what values will give me 0 in the bottom because we need to exclude them. So this is a difference of perfect squares, and it factors as x plus 6, x minus 6 equals 0. So again, if you haven't watched the recording on factoring, or you're kind of still unsure about factoring, go back and watch that recording to make sure you got factoring down. And so here we have x can't be negative 6 and x can't equal 6. And so the numbers to exclude are negative 6 and 6. Okay, so let's, these are just some examples where we excluded the values that make the denominator equal 0, and because that cannot be part of the domain. Okay, let's take a look at simplifying rational expressions. So we have here, simplify the rational expression, find the number that must be excluded from the domain. So we're doing two things. What numbers we need to exclude from the domain, and also simplify. Let's simplify first. So how we simplify is you try to factor all the different parts. So in the numerator, we have x to the third plus 3x squared. In the denominator, we have x plus 3. We can factor out an x squared term from the numerator, which will give us x plus 3, because we're taking out x squared from each of these terms. The denominator is pretty simplified. We can't simplify x plus 3. And you can see here x plus 3, x plus 3. I mean, you can think of this kind of being its own unit or term. So we can eliminate the x plus 3, and this expression simplifies to x squared. So this is the simplified answer, and it also asks us to find the numbers to exclude from the domain. Again, we're trying to find numbers that will make the denominator equal 0, because we can't divide by 0. Can't have 0 in the expression. So take the denominator to find the numbers. What can say x plus 3 can't be 0, subtract 3 on both sides. Say, oh, x can't be negative 3. So this is the value to exclude from the domain, and here's the simplified expression. Let's take a look at the next example 3, simplifying the rational expression, and then again finding the number to be excluded from the domain. So from here, we are going to also just factor. And if we factor the numerator, it's a difference of perfect squares, x squared minus 1, factors as x plus 1, x minus 1. The denominator factors to x squared plus 2x plus 1. I'll make the x chart here and putting the last number up top, finding two numbers that multiply to 1 and adds to 2, the middle term, and that's just 1 and 1. So this factors as x plus 1 and x plus 1. And so again, if you think about factoring, think about what two numbers multiply to the last number but adds up to the middle number. And so now we can try to here cancel out any common terms, and we can cancel out the x plus 1. And so we get x minus 1 and x plus 1. Okay, so there it is simplified. Now we're going to find the numbers to exclude. To find the numbers to exclude, we already factored it, so we can take this bottom factor here, which was just x plus 1, and set it not equal to 0, because we don't want it equaling 0. And solving for x, we have x can't be or can't equal negative 1. So this is a number that we're going to exclude from this expression. Okay, so we looked over two examples on simplifying rational expression. The idea is try to break it down by factoring, cancel out any common factors, and then also finding the numbers to exclude. Now let's take a look at multiplying two rational expressions. Just to do an overview of how we multiply fractions, back when you were in 4th grade, we took 2/3 times, let's say 4/5. The way we simplified it, or the way you were taught, was we multiply straight across. So 2 times 4 is 8, 3 times 5 is 15. And then you also made sure that you simplified completely. Okay, so let's use that idea, because rational expressions are really fractions with variables in them. So here, the first example we have is x plus 3 over x squared minus 4, and we're going to multiply that by x squared minus x minus 6 over x squared plus 6x plus 9. So you want to factor this completely, factor each part completely. So we have x plus 3. That can't really be factored, so we'll have that here. We're going to factor x squared minus 4. That's a difference of perfect squares because we're subtracting 4, which is a perfect square. That factors to x plus 2, x minus 2. And then the x squared minus x minus 6, that factors as, let's do it here, what multiplies to -6 but adds to -1 is 3 and 2, with the 3 being negative. So we have x minus 3, x plus 2. We factored x squared minus x minus 6. And now let's factor x squared plus 6x plus 9. That is what times what is 9 but adds a 6. That's going to be 3 and 3. So this denominator part factors as x plus 3, x plus 3. Okay, let's cancel out any common terms. We have here x plus 3. We can cancel this with x plus 3. And this x plus 2, we can cancel with this x plus 2. I think that's everything. So now we have what's left over is x minus 3 over x minus 2 over x plus 3. Okay, so here's the simplified solution after we multiplied the two rational expressions. Now, don't forget that we do have to still find the numbers to exclude. And when the way we do that is you have to look at the original problem before you cancel out anything. So take a look at x plus 2. We're going to say, all right, that can't equal 0. We have to also do that with x minus 2. That can't be 0. And also x plus 3. And this x plus 3 is the same, so we can just do it once. And so we know that x can't be -2, x can't equal +2, and x can't equal -3. So the numbers to exclude are x cannot equal -2, 2, and -3. It doesn't matter what order you put it. Right, number 5. Here's another example, x squared minus 7x plus 6 over x squared minus 13x plus 30 times x squared minus 12x plus 27 over x squared minus 8x plus 7. Again, lots of factoring. If factoring is your weakness, make sure that you go ahead and practice some more, because throughout algebra, we do lots of factoring. So let's factor x squared minus 7x plus 6 first. So what multiplies to 6 but adds to -7 is going to be x minus 6 and x minus 1. Okay, now factor this bottom part, x squared minus 13x plus 30. What multiplies to 30 but adds to -13 is x minus 10 and x minus 3. Now this part, x squared minus 12x plus 27, what multiplies to 27 and adds to -12 is again x minus 9, x minus 3. And factoring x squared minus 8x plus 7, it's x minus 7 and x minus 1. Okay, canceling out any common factors. Let's see, x minus 1, they cancel out, and the x minus 3's cancel out. And what's left are, let's see, I'll put it here. X minus 6, x minus 9, and x minus 10, and x minus 7. Okay, so now let's think about what numbers do we exclude, because that it also, we need to find the numbers to exclude. So numbers to exclude from x minus -10 are +10, because 10 minus 10 will make that 0. And from x minus 3, it's going to be positive 3. From x minus 7, it's 7. And from x minus 1, it's 1. Because all those numbers, if we substitute it back, will make the denominator equal 0. All right, let's take a look at now. We multiplied the rational expressions, and now we're going to move on to dividing rational expressions. To go over dividing fractions again, if we had divided 2/3 by, I don't know, 4/5, this should be division actually. How we do this is we multiply the first fraction by its reciprocal. Sometimes maybe you've learned it as keep, change, flip, where we keep the first fraction as the same. We multiply division, or change the division to multiplication, and then flip the second fraction around 5/4. And then we would multiply straight across and then simplify. Another way you can do it is break everything down and then simplify. So here 2/3, we have 5, and the 4 can be broken up to 2 times 2. And then the 2's can cancel out, leaving us with 5 times 3 times 2, which is 5/6. So using that idea, the keep, change, flip method for dividing fractions, we do the same for rational expressions. Again, rational expressions are fractions with variables. So first we're going to rewrite the top. So let me move this over so we can have more space. We're going to rewrite the fraction as keep the same, the first fraction or first rational expression, we're going to keep that the same. So x squared minus 2x plus 1, x to the third plus x, change division to multiplication. Then we're going to write the reciprocal, flip the second rational expression around. So it becomes 3x squared plus 3 over x squared plus x minus 2. Now we're going to factor. So we're going to factor, there's 4 parts, right? There's the x squared minus 2x plus 1. We can factor that as x minus 1, x minus 1. The bottom, we can factor, we have an x term as the greatest common factor. So let's factor out an even us with x squared plus 1. The top here, the 3x plus 3, we can factor out as 3, which gives us x squared plus 1. X squared minus plus x minus 2 factors as x minus 1, x plus 2. Okay, now we can cancel out anything that we see. The x minus 1s cancel out. The x squared plus 1 cancel out. And what's left are 3x minus 1 over x times x plus 2. Right? Don't forget that we also must find the number to be excluded from the domain. And look at what we're going to look at is, this is a little different. We have to look at what was in the original problem, like what was in the denominator. If you think about what was in the denominator, it's the x to the third plus x, or these factors. So we have to exclude everything from there. We also have to make sure we exclude everything from the 3x squared plus 3, which was the 3, if we factored it, is a 3x squared. And we also have to make sure that, because this is also in the denominator, exclude everything from the x minus 1, x plus 2. So from here, the x and the x squared plus 1, we're going to exclude that 0. For x squared plus 1, nothing will make that 0, because if I wanted to show that algebraically, we get x squared is can't equal -1. If we take the square root of -1, it doesn't give us a real answer. So we can kind of ignore the x squared plus 1, because that will never equal 0. Okay, so from the x minus 1, we know to exclude +1, and from x plus 2, we need to exclude -2. So these are the 3 numbers that we must exclude from this 0, 1, and -2. Okay, let's try another example, 7, dividing the rational expression y minus 7 squared over 4 divided by 4y minus 28/16. We're using y, but just, it works the same as x. It's a division problem, so we're going to keep the first fraction the same, y minus 7 squared over 4, and change it to division to multiplication. And then the second fraction flips around, 16 and 4y minus 28 on the bottom. So let's factor away y minus 7 squared. That's already kind of factored out. And so if you wanted to write it out twice, we can. Although maybe it's easier to see that way. And we have 16. 4y minus 28. I think we can factor out a 4 and get 4y minus 7. And then we can see the y minus 7 cancels. If you think about 4 times 4 is 16, right? So this 4 times 4 cancels the 16 out. So what we have left is y minus 7 over, I think that's it actually. So we don't have anything in the denominator, so we don't need to write that. So just y minus 7. Okay, let's find the numbers to exclude. And if we look at what's in the bottom part, it's just the 4y minus 28. Or yeah, this is the 4 and the 16. That's okay. That can never equal 0. So it's actually just the y minus 7 can't equal 0. So the numbers to exclude are just positive 7. So we exclude 7, but the simplified rational expression is y minus 7. Okay, so we looked at multiplying and dividing rational expressions. We can also add and subtract rational expressions. With adding or subtracting fractions, let me just go back to your 4th grade class. When you multiplied or subtracted fractions like 2/3 minus 1 over, I don't know, 5, we had to subtract fractions that don't have common denominators. And so when they had different denominators, the way we made it the same is multiply each other, the 3 by the 5 and 5 by the 3. And we also have to do the same to the top to keep it equivalent. That gave us 10 over 15 minus 3 over 15. And only after we had this common denominator can we combine it as a simplified fraction. 10 minus 3 gives us 7 over 15. And so that's the same idea here. When you are subtracting different rational expressions and they have different denominators, we had to make them the same. And so here we got x squared plus 3x over x, 2x minus 8 minus x squared minus 6 over x squared minus 2x minus 8. These are the same, so we don't really have to worry about common denominators here, but we're subtracting. And because the subtraction sign is in front of the whole fraction, we have to kind of think about it's kind of like having a parentheses around the x squared 6. So if we want to simplify this, we get x squared plus 3x. This negative sign we have to distribute as minus x squared, and then the minus with the negative 6 plus 6. And so this is a little tricky to remember. So you just have to remember that if you have a fraction and then a negative in front of the whole fraction, if you kind of combine it as one fraction, you have to distribute it within the terms. And so because it's a common denominator, we can combine it as a single fraction. And now we're going to simplify our combined like terms, the x squared minus x squared, that's just 0. So we have 3x plus 6, and then over x squared minus 2x minus 8. And so here's the simplified expression. Actually, we have to make sure it is simplified. I spoke too soon. Let's try to simplify it and factor it. 3x plus 6, we can factor out a 3, leaving us with x plus 2. From x squared minus 2x minus 8, we can factor it as x minus 4 and x plus 2. And now we can see the x plus 2's actually cancel out, which then leaves us with 3 over x minus 4. So that's a simplified expression. And let's exclude anything in the domain. So the bottom part, So here it's the x squared minus 2x minus 8, and its factored form was x minus 4 and x plus 2. So the numbers to exclude from x minus 4 are 4, and then the numbers to exclude from x plus 2 are negative 2. Again, what's the numbers to exclude? It's the numbers that will make the denominator equal 0. So 4 minus 4 is 0, and the negative 2 plus 2 is 0, so we're excluding these numbers. Okay, let's move on to number 9. X over x squared minus 10x plus 25 minus x minus 4 over 2x minus 10. Okay, so you can see here the denominators are not the same. X squared minus 10x plus 25 and 2x minus 10. So how we make them the same is we see what are its factors. So if we break it down, we can see its different factors here. So x squared minus 10x plus 25 factors as x minus 5 and x minus 5 minus x minus 4 and 2x minus 10 factors as 2 parentheses x minus 5. And this negative sign is we're subtracting. And so you can see they both have an x minus 5, but the first denominator is missing this 2. So let's go ahead. It's missing the 2. So let's go ahead and multiply this denominator by 2. And the second rational expression is missing a x plus 5. So it's missing this x minus 5. I'm sorry, x minus 5. So we're going to multiply it by x minus 5. Now you can see we have both denominators have 2. They both have the 2 factors of x minus 5. All right, so now we can combine it as a single fraction. On top, we got 2x minus, I'm going to put parentheses around the x minus 4, the minus x minus 4, the x minus 5, and this is over the common denominator, 2x minus 5x minus 5. Right, I'm going to, remember from the previous example, I said we have to distribute the negative. Before we distribute the negative, we got this top part out, the x minus 4, x minus 5. So we're going to do that here. We're going to FOIL this. And so we got 2x minus, I'm going to put the FOILed expression inside the parentheses, x squared minus 5x, and then minus 4x is going to give us negative 9x if we combine the outside and the inside terms, plus negative 4 times negative 5 is 20. And we still have the 2 and the x minus 5 and the x minus 5. Now we're going to distribute the negative within this parentheses. So we got 2x minus x squared plus 9x minus 20 over 2 times x minus 5, x minus 5. Phew. All right, so now let's see what we can do. The top part is negative x squared plus 11x minus 20. And the bottom part just stays as 2. Let me squeeze this in, 2x minus 5 of x minus 5. So that's our simplified answer here. We are going to now find the numbers to exclude. And the numbers to exclude, if we just check out the bottom, it's what makes x minus 5 equal 0. Well, that's going to be positive 5. So this is the numbers to exclude. Just one single so we have 5 hours, our excluded value. Okay, let's do some more practice because I think adding our I think it's good to practice lots of problems. Okay, so 6 over x plus 5 minus 3 over x minus 5. Let's see here. They have different denominators, so we have to make sure they have denominators first. And so I'm going to take the x plus 5 and multiply that by this with the second fraction. And then the x minus 5, we're going to multiply it with the first fraction, I should say rational expression. And then what we get is 6x minus 5. And then we got x minus 5x plus 5. And then we have the minus 3 times the x plus 5. Notice how we can now write it as a fraction because now they have the same denominators. Okay, let's simplify out the top. The 6x and the negative 5 we distribute, minus 30. The negative 3x and negative 5 we distribute as negative 3x minus 15. The denominator, let's just keep it in its factored form, x minus 5x. Now combine like terms up at the top, the 6x minus 3x, we can combine as 3x. The negative 30 and the negative 15 become negative 45. And the bottom, or the denominator, is just x minus 5x plus 5. And I guess we could try to factor out the top just to see. It's 3 parentheses x minus 15 over x minus 5, x plus 5. So can't really cancel anything there. So that's our simplified answer. And don't forget about the excluded numbers from the domain. We have from x minus 5, we can exclude positive 5. From x plus 5, we exclude negative 5. Okay, let's take a look at the next problem, adding, this time adding two rational expressions, x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. Again, these have different denominators. But before we kind of know what to multiply, we got to factor. So let's factor first. So x squared plus x minus 2 factors as x plus 1, x minus 1. Again, if you can't factor right away, do that cross thing and think what multiplies to the last number, negative 2, and what adds to positive 1. And that's going to be negative 2 or positive 2 and negative 1. Should have written positive 2 here. Plus 2, x squared minus 1, that factors to x minus 1, x plus 1. Okay, now we can see what the denominators are missing. So they both have an x minus 1, so that's good. But the second fraction is missing the x plus 2, so let's multiply this by x plus 2, x plus 2. And the first fraction is missing an x plus 1, so we're going to multiply the first one by x plus 1, x plus 1. Okay, so we have here x plus 1, x plus 3, plus 2 times x plus 2. I can tell this is going to be a little longer. Should have given myself more space. Actually, let's write it here. X plus 1, x plus 3, plus the 2, x plus 2, and the denominator is going to be 3 factors, x plus 1, x plus 2, x minus 1. Let's FOIL these guys out. It's going to be x squared plus 4x plus 3. We're going to distribute the 2x plus 4. And the bottom just the same, x plus 1, x plus 2, and x minus 1. We combine like terms, we get x squared plus 6x plus 7 over x plus 1. And can I squeeze this in x plus 2? And I'll just squeeze the x minus 1 here. All right, so I think that's it. I don't think we can factor out the top. There's nothing that multiplies the 7 and adds the 6, I don't think. Let's try. Does anything multiply to 7 and add to 6? No, I don't think so. So that's it. So here's the simplified expression. And now we're going to include numbers that make the denominator 0, which are positive 1, negative 1, and negative 2 from these 3 factors. Okay, one more. Got x over x plus 1 minus 3x plus 2 over x plus 1. So it's subtraction. They both have a common denominator, so don't need to worry about anything there. I'm trying to making the same. They're already the same. We got x minus. Let's make sure the negative gets transferred or distributed with 3x minus 2. And we have a common denominator of x plus 1. And so we got x minus 3x minus 2. We can combine these x's, 1x minus 3x, and there 2x minus 2 over x plus 1. Looks like they both have a common factor of negative 2. Let's factor that out. We get negative 2x plus 1 over x plus 1. And it just happens that here the x plus 1s cancel out. So we get an answer of just negative 2. So that's a simplified answer. Remember to find the numbers to exclude. So it looks like we only need to worry about what makes x plus 1 equal 0. So we're going to exclude negative 1 because negative 1 will make x plus 1 equal 0. Right. In this recording, we have covered how to add, subtract, divide, multiply rational expressions, as well as finding the domain, which just means the numbers to exclude. Feel free to reach out with questions. If anything that we've gone over was confusing or you need more clarification on.